In this video, we're going to talk about least common multiples and greatest common factor. The key to both of those is doing prime factorization of each number that you're given. When you're trying to find the least common multiple of a pair of numbers or the greatest common factor, what we want to start with is doing prime factorization of each number that we're given. So let's go over prime factorization to start with. Okay. Take 60. We're going to use a factorization tree, a factor tree, and we just start factoring 60. We're like, okay, what are two factors of 60? Well, 6 times 10, the product of 6 and 10 is 60. And we're going to keep branching these out until all of our branches end with a prime number. So 6 is composite. We know that 2 times 3 gives us 6. Both of those are prime numbers, so both of those branches are done. And then 10 is also composite. And 2 times 5, the product of 2 and 5, is 10. And both of those numbers are prime. So each of our branches now ends at a prime number, so we can write the prime factorization of 60 as 60 equals 2 times 2 times 3 times 5. Okay. Now, let's take a look at another example. 19. Well, 19 is prime, right? And we're done. There you have it. That's all you need to do. There's no prime factorization. You just write, that's prime. Okay, now that we've gone over prime factorization, let's look at finding the greatest common factor for a pair of numbers. And here we're given the pair of numbers 84 and 14. So we're going to start with 84. And 84. Well, I like to think, well, my approach is always it's even. So one of the factors is 2. And we have 2 times 42 gives us 84. 2 is prime, so we're done with that branch. 42, well, that is 7 times 6. 7 is prime, so that branch is done. 6, we already talked about, is 2 times 3. Both prime numbers, all our branches end with prime numbers, so we can write the prime factorization of 84 is equal to 2 times 2 times 3 times 7. Now, it's useful to write in order from least to greatest when you're writing out the prime factorization. It's going to help you when it's come to finding the greatest common factor. Next up is the number 14. Well, what multiplies 14? 2 and 7. Both prime numbers, so prime factorization for 14 is going to be 2 times 7. Okay, now we want to find the greatest common factor. Now that we've done prime factorization for both our numbers, we want to find the greatest common factor. The greatest common factor is going to be that number, the biggest number you can find that is a factor of both 84 and 14. Okay, so we pair up all the common factors. There is 1, 2. Each share a single 2 as a common factor, and each share 7. So our greatest common factor, or GCF, is going to be 2 times 7, or 14. So 14 is the greatest common factor of both 84 and 14. And something to note is we can write 84 as equal to 14 times 6, right? 6 is these two leftover factors that we didn't use in determining the greatest common factor. Right? So there it is, finding greatest common factor. That can be useful in solving a variety of problems, which we won't go over in this video. All right. But we can also use the greatest common factor to help us factor things. Now, we're not quite to that point, but we're going to use the distributive property to find the sum of two numbers. So recall that the distributive property states that if we have a times the quantity b plus c, then we can rewrite that as a times b plus a times c. And it works for subtraction as well. So let's take a look at this example right here. We've got 3 times the quantity, 5 plus 2, right? And the distributive property says that is equal to 3 times 5 plus 3 times 2. Okay, well, let's go through and evaluate each side of the equation separately to confirm that what we get in the end is equal. So on the left, we have 5 plus 2, which is 7. So we have 3 times 7 on the left. And on the right, we have 3 times 5, which is 15, plus 3 times 2, which is 6. All right, now make sure we're just working separately each side. 3 times 7 is 21. And 15 plus 6 is also 21. So there you have it. 21 equals 21, and there's the distributive property in action. So we're going to use the distributive property and the greatest common factor to find the sum of two numbers. Now, most of you could look at this and say 34 plus 51, yeah, that equals 85. But what we're really trying to do is set up some skills that we can use in the future. So we're using examples, that are easy for us to already solve using our existing skills, and that way we can check our work when learning a new skill. So the first thing we need to do, the first step, is to find the greatest common factor of 34 and 51. So we're going to do prime factorization of both. 34, that's an even number, so we know 2 times 17. 51, well, the digits 5 and 1 add up to 6. When you add up the digits in a number and their sum is a multiple of 3, we know that 3 is a factor. Fun little trick. So 3 times what number gives us 51? That would be 17. So we have 34 is equal to 2 times 17, and 51 is equal to 3 times 17. So our GCF is 17. Now we're going to rewrite each of those numbers as a product of two factors, where one of those factors is the greatest common factor. So we'll take 34, and we're going to write 34 as, I'm going to put the GCF in a different color, 17 times 2 plus the 51 we'll need to rewrite as 17 times 3. So this is still equivalent to the original expression we have, 34 plus 51, but now we have 17 times 2 plus 17 times 3. You might recognize this as the right side of the equation in the distributive property. So we can use the distributive property in reverse, and we can say, okay, this numerical expression here is equal to 17 times 2 plus 3, right? So we've used the greatest common factor and the distributive property to rewrite the original expression that we were given, the sum of two numbers, in terms of the greatest common factor times the sum of the remaining factors, right? Now, we were asked to find the sum though, so we can finish this problem off. Make sure I got the right color. Is okay, working inside the parentheses first. 2 plus 3 is 5, and that's times 17. So I have 17 times 5, which is 85. And that matches what we originally got just by adding those two numbers up. So we know that our technique worked, and this is how you can use greatest common factor and distributive property to find the sum of two numbers. Yes, in this case, it was a lot more work, But again, we're building a new skill here, and we want to be able to check our work as we go. What's next? Last thing we're going to cover in this video is least common multiple for a pair of numbers. So we're given the numbers 6 and 12, 6 and 20, and we want to find the least common multiple. All right, so remember what multiples are. We got 6, and multiples of that would just be like 6 times 1 is 6, 6 times 2 is 12, right? These are all multiples of 6. And we want to find the least common multiple of 6 and 20. So that's going to be the smallest number that is both a multiple of 6 and 20. So we're going to keep filling this out. And this is kind of how we learned how to do it in the past. We kind of ran out of space there, so we'll stop there. That's for 6, and then for 20, multiples of 20 are 20, 40, and 60. And we can stop right there because we have found our least common multiple, and that is 60. Now, I like to call this the old and slow way. We have a new way that we can find the least common multiple, which is going to be handy because when working with maybe bigger numbers or more complicated numbers, this is going to be great. So let's use that new way, and it involves prime factorization. All right. So we have 6 and 20. 6 is 2 times 3. And 20 is 2 times 10. 2 is prime, and 10 is 2 times 5. So we've branched that out. It all branches in prime numbers. And 20 is going to be equal to 2 times 2 times 5. Okay. So here, what we want to do is we're not looking for common factors. What we're looking for is the least common multiple will be the product of each factor, the greatest number of times each factor appears in either prime factorization, right? So here we have 3 occurs once, and we have 5 occurs once, and in this one, and 2 occurs twice. Okay, so yeah, there's a 6 as a factor of 2 is a factor of 6, but there are 2 2's that are factors of 20. So when we're looking at to find our least common multiple, that is going to be the product of those numbers. So that's going to be our least common multiple is going to be 2 times 2, right? Because remember, we're looking to find the greatest number of times each factor appears in either prime factorization. So 2 appears twice in the second one. So that's why we write it twice. Now there's no 3's in the second one, but there is in the first. So we can include that 3 there. And there is a 5. 1 5 in the second number. So our least common multiple will be the product of 2 times 2 times 3 times 5. 2 times 2 is 4, and 3 times 5 is 15. So we have 4 times 15, which is 60. Right? Which we already confirmed using our previous method of just listing out the multiples. Again, this is a technique, a skill that we can use then when our numbers get a little more challenging, a little more difficult to work with, it's going to be better than just trying to list them out. All right, so today in this video, we covered prime factorization, greatest common factor, using the greatest common factor and distributive property to find the sum of two numbers, and least common multiple.